This is Geometry Lesson 5 on page 157. Isosceles and equilateral triangles. Okay, so let's just talk about triangles, all right? We can name triangles by their sides, and we can name triangles by their angles. So just thinking about sides, what are some names for triangles based on their sides? Yes, Jack?
Scaling, which is
Scaling.
neither equal.
That's right. That means no side is equal. That's right. What is another name for triangles based on their sides? Megan? Equilateral. What is equilateral? Yes. All sides are the same. Yeah.
Isosceles if it has at least two equal sides.
Isosceles. Two equal sides. The third one not equal. Okay? What then are names of triangles based on their angles? Selby?
Acute.
Acute. What is true about acute?
The angle is less than 90 degrees.
All of them. All three of them. All three of them are acute. Landry?
A right triangle.
Right. What is true about a right triangle?
One of the angles is right.
One of the angles is right.
They start obtuse.
Obtuse. That's the other one. Yes. Obtuse. How many obtuse angles does it have? Yeah. At least one. There is one more. What is it, Christopher?
Equal. Let's see that. Equal angular.
Equiangular. That is correct. What is true about that?
If all sides are equal.
No.
Oh, all angles.
All angles are equal. Yes.
A triangle can't have more than one obtuse angle, right?
Correct. Only one. One angle's obtuse. In this one, all angles are acute. All three. In this one, only one of them is right. In this one, only one is obtuse. In this one, what is the measure of every angle in an equiangular? What is it, Elliot?
Just the 60.
60 degrees. So, could an equiangular triangle also have another name? Yes?
Well, if all the angles are equal, all the sides are equal, right?
That is true. Every equiangular triangle is also equilateral. Would it also have another name? Yeah.
Would it also be equilateral?
Yes, every equiangular is an equilateral. There's one other name that it would be. Yes?
Acute.
Acute. That's right. Right?
What?
Every
Oh.
equiangular triangle is acute. Right?
Something. Oh yeah.
But is every acute angle equiangular? No, they're not. So there's something called a regular triangle. Regular. You need to know what this word regular means. Does anybody know what the word regular? If it's a regular triangle or a regular polygon. Anytime you hear the word regular, that means it is both equilateral and equiangular. And equiangular.
So if it's equal angular, then it has to be equilateral.
That is correct. And if it's equilateral, it has to be
Ooh.
equiangular.
Oh yeah. Just flip it around.
Correct.
And so then it's also acute.
By definition, it's also acute because what's the measure of every angle? An
60
acute
degrees.
angle.
Yes. It's under 90 degrees.
Right. Okay, so you see how we can have multiple definitions for the different triangles based on sides, based on angles. All right. Now, there's some facts that we can learn. We just learned some facts. If I told you the triangle was equilateral, then what can you know about the triangle? Yes.
All the sides are equal.
All the sides are equal. That is correct. What else can you know? Yes.
Would it be also equal?
Yes. If it's equilateral, it's equiangular. Then what else can you know? Yes.
Acute.
You can know it's acute. What else can you know? Yes, Jack?
They don't have the same area. Oh wait, never mind.
There is something about their area, but it would not be the same because I could have an equilateral triangle. Maybe that's that size. And maybe that size, right? But what else can I know if I know those things? I can know the measure of any angle, can't I? I can know that the measure of the internal angles are all 60 degrees. Right? Does that make sense? So early on, I taught you guys that the length of the side of a triangle, what does it sort of dictate? The length of the side of the triangle, what does it dictate? Do you remember? If I have an obtuse angle or triangle, what does it tell me about the side opposite it? Do you remember? As opposed to if I have an acute angle and the side opposite it, how is that different? Yes?
One's larger and one's smaller,
So a bigger angle
so longer line.
makes the side opposite it bigger. So big equals big, right? If the angle is big, the side opposite it is also long. If the angle is small, the side opposite is going to be shorter. Got it? Such that if I had this triangle, okay, we're going to call it ABC, and we'll say that's 75 degrees. We'll make this 100 degrees. Okay, just don't look at the angles, all right? We'll call it side A, C, and B. All right, which side would be the longest side? What, Alexis? B. What would be the shortest side? Elliot? C. You see that? The angles, even though this is not a very nice visual drawing, the angles opposite the side, the angle sort of dictates the length of the side opposite it. We will actually, by the end of the semester, use trig to calculate that using angles. All right? Now, because of that, if I have an isosceles triangle, if I have an isosceles triangle, because the length of a side dictates the angle opposite it, then I have two equal angles. So if I have an isosceles triangle, then I know that the angles opposite them are also equal. Right? So if we labeled this A, B, C, right? And this were A, B, C. So if side B equals side C, then angle B equals angle C. What makes this a great thing is, obviously a masterful God made this, but if I tell you that that angle is 50 degrees, can we calculate the other angles? Yes, what are they?
Maybe just 180 degrees minus 50, 130, which would be.
And then you take
65.
half of it, right? So it's 180 minus 50, which is 130, and then you take half of it, right? Which is what? 65 degrees. Each angle is 65 degrees, right? Hey, can I have that book? Can I have that book, please? All right, 65 degrees. I'll give it to Mr. Lindholm. He'll have it for you. So isosceles triangles, their sides opposite are going to be equal, right? And that is Theorem 9. If two sides of a triangle are equal, then the sides opposite them are also equal. Okay, the inverse is also true. If I have a triangle and I tell you that those angles are equal, then what can I know? If I tell you angle E equals angle F, then what can I know? Yes.
That DF and DE are equal.
Right. Then these two sides are also equal. Got it? It goes both ways. Did you see that? So if the sides are equal, then the angles opposite them are also equal. But if I have two angles equal, then the sides opposite them are equal as well. Make sense? Okay, so do you see how this can play into proofs? If I tell you it's an isosceles triangle, what can you know? Right, David?
That two of its sides are equal.
I can know that two of its sides are equal. What else can you know, Landry? Then those two angles are equal as well. That's Theorem 10. All right, look at the corollaries to that. An equilateral triangle is equiangular, right? And an equiangular triangle is equilateral. All right, so we're going to do a proof having to do with this. All right, so I'm going to draw it. There's so many interesting things about isosceles triangles. All right, so here's the given statement. AB equals AC, and D is the midpoint of BC. Here's what we want to prove. Angle BAD is congruent to CAD. All right, so what is going to be my first statement and my first reason? Yes, David.
AB equals AC.
And the reason?
Given.
Given. Christopher, what else?
D is the midpoint of BC.
And the reason?
Given.
Right. Okay, now where do I go from the given statements? What question am I asking myself? Yes, Isabella?
What can you know?
What can you know? So what can I know from the fact that AB equals AC? Elliot?
That angle ABC and angle ACB are equal.
Angle ABC
C,
is congruent to angle
CB.
ACB. That is correct. Why?
Theorem 9. Or I guess.
Right, so he said theorem 9. Don't memorize the numbers.
It's just that.
Okay, I say that because I'm going to tell you why. I read math textbooks. No surprise to you, maybe. And the theorems don't all have the same numbers. Crazy. So we have to use words, not just theorem, whatever. So what are some words, Elliot?
If two sides of a triangle are equal, then the angles opposite them are equal.
That's right. If two sides of a triangle are equal, the angles opposite them are equal. That is true. All right, very good. So we have two equal angles. What can I know from D being the midpoint? Yes, Megan.
You can know that BD and DC are equal because the midpoint divides one into two.
Yes. Midpoint divides a segment into two equal parts. All right? All right. What am I trying to prove? I'll write that in a different color. I am trying to prove that this angle equals this angle. I can already prove it, but is there another part that I possibly know? Yes, Elliot.
Side angle side.
I can prove it side angle side, but is there another part that I could already prove is equivalent in those two triangles? Does everybody see three triangles?
3.
Three. Do you see three? Just making sure. Everybody sees three. What else?
Triangle ABD is equal to ADC.
Correct. But is there another part in the triangle on the left that I already know is congruent to the part on the right? What, Elliot?
Just reflexive property. AD equals AD.
Correct. I could have already said AD equals AD. Got it? Let's not miss it. We're not going to say that right now. Yes, David?
May I go get it?
Yes. All right, so we can say they are congruent. Give me those triangles again, Elliot. Triangle.
ABD is equal to A.
And we're going to use the congruent sign. To A what?
CD.
ACD. ACD. And why did you say?
Because side angle side.
Yeah. Side, angle, side. Remember, it's three letters. They never spell a bad word, right? All right, where am I going from here? No, Elliot knows them all. We're going to let somebody else answer. Where are we going from here? Yes, Megan. That's right. It's this because corresponding parts of congruent triangles are equal. Right? Are you getting this? Sort of? A little bit?